Hello and welcome to this video on wavelength and frequency. So the first thing I need to be able to do really is describe what we can see when we're looking at a wave diagram. First of all, we'll just draw a wave diagram here. I'm going to draw a transverse wave for you, such as any of the electromagnetic waves. They're all transverse. So we see this sort of pattern. This line in the middle is called the rest position. This is where the particles in the wave would be if there wasn't a wave passing, so if they were at rest, if they weren't vibrating. The top bit is crest, or what we call the peak, and the bit down the bottom of the wave, that's what we would call the trough of the wave. We also need to be able to label the wavelength. Sometimes you'll see a wavelength represented by the symbol lambda there. A wavelength is a distance travelled by one complete wave cycle, or the distance in between two identical points. So here I've labelled up the distance between two peaks. It could be two troughs. And some common mistakes that people might make when labelling a wave is they get a bit lazy here and it's not exactly from peak to peak. Or they might label it up as half a wavelength, so from the top to the equivalent bottom there. That would be incorrect. That's only half a wavelength. You sometimes see from one point where the wave is on the rest position to the next time it's on the rest position, again that is only half a wavelength. It needs to be a full wavelength, either one of those examples there. We could also go from trough to trough. So we can identify wavelength from a wave diagram, but we need to be able to define it. We might have the question, what does wavelength mean? Basically, wavelength is the length of one complete wave cycle. Or we could say it's a distance travelled from two adjacent identical points on the graph. So from peak to peak or from trough to trough. The key here being that they are the adjacent peaks or adjacent troughs. And frequency is just the number of complete waves passing a point every second. So if 100 waves pass a point in 1 second, the frequency is 100 hertz. Hertz there is the unit of frequency. We can write hertz or we can represent it as Hz. But frequency is just the number of complete waves passing a point in 1 second. Sometimes you'll be given the information to calculate the frequency of a wave. In this instance, you'll be given the number of waves passing a point in a given unit of time. And all you've got to do really is just divide the number of waves that pass the point by the time it took for those waves to pass the point. So the number of waves divided by the time taken, and that will give you the frequency in hertz. For example, if 15 waves were to move past the harbour wall in a 5-second period, what would be the frequency of those waves? Well, we've got the number of waves, which is 15, divided by the time taken for those waves to pass, which is 5. 15 divided by 5 equals 3 hertz. That's 3 waves per second. You might be asked to measure wavelength from a wave trace here. So here we can see we've got the amplitude of the wave up the side, the distance travelled along the bottom, and you can see there are 2 complete wave cycles there over that 16-metre distance. So if there's 2 waves in 16 metres, one wave must have been 8 metres. Another way would be to look from 0 to complete one wave cycle. So over a crest and up from a trough, 0 to 8, so that would be 8 metres. Or here we look at marking up peak to peak, and you can see the peak there, the first peak was at 2, the second peak's at 10. 10 take away 2 is 8 metres. So there's 3 different ways really of working out the wavelength there. Total distance divided by the number of waves, distance for one complete wave cycle, or distance from peak to peak. We could have done trough to trough also. So you might be asked to measure frequency from a wave diagram, and just remember that frequency is the number of waves divided by the total time taken. In the first one here we can see there is one wave in 4 seconds, So 1 divided by 4 equals 0.25 hertz. In the second one, we've got 2 waves in 4 seconds. So 2 divided by 4 equals 0.5 hertz. And the bottom one, we've got 1, 2, 3 waves in 4 seconds. 3 divided by 4 equals 0.75 hertz. It's as easy as that. Now let's look at some exam questions here. So first one, for 2 marks, describe what the term wavelength means. Second one, calculate wavelength shown in this diagram. The diagram shows how far waves travel in 0.4 seconds. Can you calculate the frequency of the wave? And a sound wave vibrates 30,000 times in 2 seconds. Can you calculate the frequency of the wave? Pause the video and have a go at these questions now. We'll catch back with the answers shortly. Good luck. So welcome back. Here we're asked to describe what the term wavelength means. Wavelength is the length of one complete cycle, or the distance between 2 adjacent peaks or troughs. You might get asked to indicate these on a diagram rather than write the descriptions. Calculate the wavelength shown in this wave diagram. So we can see there we've got 2 wavelengths over the 16 centimeters. So we do 16 divided by 2 equals 8 centimeters. Or we could just look from the start of a wave, track it all the way through to the end of that complete wave cycle and see it's 8 centimeters. Or we could go from peak to peak, 10 take away 2 there, 8 centimeters. This diagram shows how far a wave travelled in 0.4 seconds. Calculate the frequency of the wave. So we can see that there are 2 complete waves in that 0.4 seconds. 2 divided by 0.4 will tell us the frequency, and that gives us 5 hertz. Sound wave vibrates 30,000 times in 2 seconds. Calculate the frequency. Number of waves divided by time. 30,000 divided by 2 gives us 15 hertz. Okay, we should now be ready to try these exam questions fully on our own. First one, describe what is meant by the term frequency. And then moving on, a group of students are investigating waves and produce this graph. Can you state the number of wavelengths shown in this image? Can you then calculate the wavelength of the wave? And then, knowing that this image shows a wave over a time period of 0.1 seconds, can you calculate the frequency of the wave? Good luck. Thanks for watching this video on wavelength and frequency. Hope you found it useful, and we'll see you again soon.